All right. Well, we are moving on to another new rule today. So under our belts, we should have the constant rule, the power rule, the product rule, and the quotient rule. Those are the four main rules that we have. So today we're going to take a look at another one to handle a new kind of situation. But I'm going to just show you examples of the input and the output for finding the derivative, and then you're going to help formulate the rule. Okay, so this you got to concentrate to figure out what's going on. And I have a function up here, which is kind of a wacky function. You can see it's the sine of the cosine of bx then minus x. And I'm letting b go between negative 10 and 10. And so it's usually fun when it gets to be right about there or so. So I'm going to stop this. I'm going to stop this at about 8. That looks pretty fun right there. Okay. And then here is the derivative. Now this computer is not very fast, so it's hard to see that. So what I'm going to do is I'm going to graph the derivative. And there's the derivative. Okay, so yeah, I'm going to be switching over soon. So the green dot, the green function is the derivative of the red function. So there's a certain characteristic of the red function which is characteristic of all the functions that we're going to do today. Okay? So your first job when we do this is to look at the function and try to figure out how it's different, how each of these are different than the ones before us. Okay? Because this is a new rule. Okay? So we're handling different kinds of functions that we couldn't handle with the old rule. Okay? So everybody look at this. Try to imagine or start to formulate an idea about how this one is different than the other one. Okay? So now I'm going to give you the derivative of this. So with the sine of 5x, put it in here, chunka, 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 and this is what comes out. You might want to jot that down. We're going to try to formulate a little pattern. So I'm going to just start this over. G of x is the sine of 5x. Okay, g of x is the sine of 5x. And then the derivative is the cosine of 5x times 5. Okay, you're going to start cranking away. First person that gets it, it's gold medalish. Lots. If you take a look at our list, we've got, it's on the assignment guide for all the ones we're going to learn. But then there's other situations that we don't even cover. Okay, new function. So mathematics is the study of patterns. So what Newton did was he tried all of this type of problem and he found the derivative of them and then came up with the chain rule. Okay, so all of these are a certain type of problem. Okay, so what happens next? Ooh, that's weird. Okay. So that's 6 times x squared plus 4 to the 5th power multiplied by 2x. Okay, And then, because this is what the function looked like. X squared plus 4 to the 6th. Okay. So you got that one down. Anybody got an answer formula yet? Okay. So this is how it works. Sometimes it takes months to come up with a solution. Okay. This is another example of the kind of problem that the chain rule can solve. We cannot do this with any of the old methods. This is not multiplication of the sine of x times the cosine of x. It's the sine of x of the cosine of x. Okay? Okay? So this is not a product here. Well, what do we have here? So it's the cosine of the cosine of x multiplied by the negative sine of x. Okay, we have one person with the possible. Okay, 2.5. Okay, Bailey, you got something?
So you take the derivative of the, okay, so for this example, you take the derivative of cosine, which is sine, and then you leave the cosine of x, which is how it is, but then you multiply that by the derivative.
Okay, so can you say that one more time? Or add? Sam, can you add to it? Or did you?
I'd say you take the derivative of the sine and keep the cosine the way it is.
Keep it.
And then multiply it by whatever's inside the bracket.
Whatever's inside here.
The derivative.
The derivative of what's inside. Okay, let's check that out. So he's saying take the derivative of the sine of x, the sine function, and then you just leave the cosine in there. Okay, so if I cover this up, is that what that is? Yes, that's it. And then he said, well, they both said, then multiply by the derivative of the whatever was inside. And the derivative of the cosine is the negative sine. So I think we got something here. Okay, let's just go back and check it. Okay, picture this one. Okay, this is one that we did. So you see it's like something to the 6th power. So like something to the 6th power is 6 times something to the 5th power. And then we multiply it by what's in the derivative of what's inside. So we come up with this. Okay. Okay. One more. This was the first one we did. So the derivative of, like, I don't know, I'll call it the outside function. The derivative of the sine of x is, the derivative of the sine of 5x, or derivative of the sine is the cosine. And then multiply it by the derivative of what's inside. And then we get it. See that? Yeah.
Like, if our derivative is, or if our original function is h of x, is f of x of v of x.
Hold that thought. Hold that thought.
Yes, that one.
Okay. This is the chain rule. We're going to do the chain rule. Okay? What's the name given to when you have a function inside of another function? There's a name for that. Used it last year. It's the whole f of g thing, or g of f. Composite. It's the composite function. Who got it?
I was thinking it, but I didn't have the.
Well, then it doesn't count.
Doesn't count.
Okay, so the chain rule is good for finding the derivative of composite functions. When there's something inside of something else. It doesn't work, I mean, The product rule doesn't work for it. Change the quotient rule doesn't. It has to have its own rule, and that's what it has. Okay, everybody try to write the answer to this. What is the derivative of f of g of x using the techniques that we have been just taking a look at what we got? Because this is the rule right here. Okay, ready? I'm going to just do it. Chunka, chunka, chunka. Do, 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 do. It should be, did I get it right? People are looking at me. I got to restart it. This is supposed to be F, not H. That's okay. Just get the main rule wrong. Yeah. So back to here. It was h of x is equal to h or f of g of x. And then over here, cover up my finger here, it's f prime of g of x times g prime of x. Okay? Now, this is what allows us to do something like this, and we're going to do this at the end of the hour. Okay? After we do a couple of them, we're going to do a bunch of them now together, just to make sure that you got it. We're applying the chain rule to find the derivative. All right, from the top.
Corey thought that you had a different box from the other box that we used. She thought that you were getting different boxes.
I have no comment. Okay, so let's do a couple here. I'm just going to make these up. These are problems that all fit the model of the chain rule. So what if I have the cosine of 6x? Okay, start off simple just so you get the picture. What is dy dx? And how you write it matters. Yeah.
Why can't you just write y with the little thing?
You can do either one.
It's okay.
You can write y prime, or you can write dy dx. We have these interchangeable words.
Okay.
Okay, here's how the chain rule works. We take the derivative of what we see as the outside function, which is the cosine. So the derivative of the cosine is the negative sign, and we leave the 6x inside. Okay? That's the f prime of x part. But then we look inside here and we say, hey, what's the derivative of that? And the derivative of 6x is 6. And so when we simplify it, it would be negative 6 times the sine of 6x, and that's what y prime is. Okay? All right, next one. Y is equal to 4x minus 3 to the 13th. I suppose you could just multiply that all out. Would it work? And then take the derivative? Yep, that would work. There's got to be a better way. Okay, so okay, so here what you see is you gotta actually see like the big picture. The big picture here is that I have something to the 13th power. It's kind of like the power rule. You have to see it like this. So the derivative of this thing is, to the 13th, is 13 times 4x minus 3 to the 12th. That's the outer function that we're finding the derivative of. Okay. And then we multiply by the derivative of what's inside, and the derivative of 4x minus 3 is 4. So that would make this 52 times 4x minus 3 to the 12th. A lot faster than multiplying it all out. Thank you, Newton. Okay. And just bring up any question that you have along the way here. Okay, new one. How should we rewrite this? Say it again. Were you going to factor it? No. X squared minus 4. Yeah, what do you say? Yeah, that's the only way to handle this one. So we're going to just rewrite it. It's x squared minus 4 to the 1/2. And now it's in the form of something to the 1/2 power, which matches the power rule. So the derivative, y prime, is, we handle this like a power rule where we've got this thing to the 1/2. So it's 1/2 times x squared minus 4 to the 1/2 minus 1, so it's the negative 1/2. And that's only the first part, right? Because that's to the outside. Then you got to multiply this by 2x, because that's the derivative of what's inside. You see that? You getting the hang of it? Okay. We have all of these different kinds of composites. Let's clean this thing up. I spy x over the square root of x squared minus 4, because the 2's cancel. This guy cancels with that guy. Okay, good. Okay, so you do this one on your own then. Do y is equal to the tangent of x squared minus 3x plus 7. Yeah.
Why is it going to just stay the same as the derivative of x minus 2?
X minus 2.
So you just took the square root of, right, plus n. Oh, plus n.
Do we get solved?
No.
No. Okay. Say the question again.
If you took the square root of x squared minus 4
Mm-hmm.
and then found the derivative, would that give you the same answer as what we just found?
Yeah. Except finding the square root of x squared minus 4 is kind of hard because we can't. It's a polynomial, and we can't take those. So it's the concept is the same, but we can't. Oh, you know what we should do? Okay, if you want to pay attention to this, let's do that. Y is equal to the square root of, say, x to the 6th. Okay. Let's do this using the new rule. Okay? This, using the new rule, chain rule, I would write this as x to the 6th to the 1/2. Okay? Then applying the rule, it would be 1/2 times x to the 6th to the negative 1/2 multiplied by the derivative of x to the 6th which is 6x to the 5th. Right? This would be using the chain rule on this example. Well, what the heck does this give us? 6 and the 2, that gives you a 3. X squared to the negative 1/2, that's x to the negative 3 times x to the 5th. And then this gives you 3x squared as an answer. Okay? So let's see if the rule works. Sam said, well, can't you just take the square root of it first and then find the derivative? Well, what's the square root of x to the 6th? It's x to the 3rd. And then the derivative is 3x squared. Same thing. Okay? Now, the problem is, you can't take the square root of x squared minus 4 as it is, so that's where we get stuck. Okay, how'd you do? How'd you do? Y prime, derivative of the tangent is secant squared of x squared minus 3x plus 7 multiplied by 2x minus 3. Raise your hand if you got that one right. Sweet. Okay, I think you're ready now. Let's do the one on the board. The one on the board says this. It's the sine of the cosine of 8x. So here's my function. This is number, actually we can do it right back here. Oh, Swivl didn't follow me anyway. Okay, here we go. So y is equal to the sine of the cosine of 8x minus x. If you do this right, that means you really understand it because you got to do something special for this one. Something weird happens about 2/3 of the way through the problem. Did you spot it? Here we go. Y prime equals, following the rule, the technique that we've said, the derivative of the sine of something, right? So is the cosine of the something. So we do the cosine of 8x minus x, like this. Everybody get the first step? Okay. Now we got to multiply by the derivative of what's inside. Okay. What happens here? What's the derivative of the cosine of 8x? Derivative of the cosine of 8x, wait a second, there's another one inside of another one, right here. So that's not a problem now. The derivative of the cosine of 8x, that's going to be negative sine of 8x, no, times 8. That's that part. Then minus the derivative of x, which is 1. So it's minus 1. That is the correct answer. Okay? So every time you have to find the derivative, you have to analyze. Do I have to do a chain rule? And here we had to do a chain rule to begin with, but then within the chain rule, we had to do another chain rule. Jenny? Okay, so that's a good point, because I haven't really explained why you multiply it. We know how it works. We know what it is, right? But we don't really know why it does what it does. Okay? Great segue. So, hold the thought on that one, because I'm going to use that one, I think. All right, here we go. So, all right, here we got, this is an explanation of why the rule works. Okay? Y is equal to, no, sorry. No. Shush. Okay, so u to the nth. Okay? Where, no, I'm just going to make it u. You got me. Where u is equal to, I gotta do this again. Okay, I gotta do my little thing here. Okay, I got it. Why? Shoot. Okay. I know, I forgot it. Where u is equal to g of x. Y is f of u. No pun intended. I've been working for 5 minutes to be able to write that. Okay, so if this is the case, then yeah, save this. I'm going to get rid of this. I don't need to yet. Okay. I'm all over the board. Okay, so if this is the case, tell me what y is. F of g of x. Right? Okay. So y is equal to f of u and u is equal to g of x. That implies that y is equal to f of g of x, which is the rascal that we're trying to figure out today. Right? Okay. Now, if y is equal to f of u, okay, then y prime the derivative here is
I really hope somebody's writing in pen right now. That's why I know, I'm just waiting.
yeah. Okay. Okay. I do know this. Okay. All right, we have to do a quick little side lesson, okay? Side lesson. Okay. So, we use y's and x's like all the time. Okay? We're not going to transition to other letters. Okay? So when we take the derivative, when I would say, oh, look at y is equal to x squared, then I'd say find the derivative of y, and I'd say dy dx, right? And this is equal to 2x. And I say that's the derivative of y with respect to x. Okay? If I give you something like a is equal to pi r squared, then when I say find the derivative, listen carefully, I'm saying find the derivative of a with respect to r. You see, because that's how the variable works. Go find the derivative, by the way, on this. Wait a second. Area, circumference. What?
Everybody's mind's blown and I'm just, okay.
That's the area formula and the circumference formula?
Yeah.
Okay.
I'm excited so.
All right, so I'll give you another one. W is equal to 4t cubed. Okay. So when I write the letters for the derivative, dw dt equals 12t squared. Okay? Now, back to what I was saying.
Why?
Oh. Okay. All right, so this is what I want. And I don't know why I can't get there, but let me show you what I want. dy dx is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. Okay? Look at the du's. They cancel out. Okay? This is going to answer your question. I promise. So if y is a function of u, okay, what is the derivative of y, okay, if it has u's in it? What is the derivative of y if it has u variables in it? dy du, right? Okay. What is the derivative of u if it has x's in it? Derivative of u with respect to x. So what I'm saying here is you got to link all the things together. If y is equal to a function of u's, and u is a function of x's, then the derivative of y can be written in terms of x. Therefore, if y was equal to that, and u was equal to that, then dy dx is actually equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x, which is the same as f prime of u, that's the derivative of y with respect to u. Okay, that's the outside one, multiplied by the derivative of u with respect to x, which is g prime of x. And if you plug your u back in here, you get f prime of g of x multiplied by g prime of x. Did that make sense to anybody? Okay. Watch it again on the thing, but just skip like the 20 minutes where I was doing that.
Wait, petition that if we get a t-shirt, we have y equals f on it.
Derive that. Okay. Now, so you may have noticed this up here. Okay. My parents actually went to Russia, and this is bought from in Russia. So, okay, this is a function. Okay. So to find the derivative, we just find the derivative of it. But then we got to look inside and see if there's anything inside of it. If there's something inside of it, we have to find the derivative of that one too. Okay? And you multiply them, just like we proved right there. So you multiply those derivatives. But just to be safe, you got to make sure that you look inside this one. And if there's something inside there, then what? You got to find the derivative of that one too. Okay? And you keep on going down the chain. The chain. And so we've done some where there was one thing inside of another, but you know what? We can do lots and lots and lots. You could have... Okay, fine. All right, so this has been at my parents' house for a long time, and then I have this little niece. That one's broken. I probably broke it. And so, of course, as a... Watch out for the baby. Oh, yeah. Okay. So then you take that one off. So then, so the whole time I played with these things, I thought this was it. Until my niece, who was like 8 years old, was playing with it, and she said, "Look, Uncle Dean." And it comes across. And the only thing you could fit in there is like a small piece of rice. And so that's the deal. And it never swallowed it. Isn't that crazy? And the guy, it even has a face on it.
Oh my god!
It's got a little smiley face on it. Show the camera. And you gotta open it up. There it is. Okay. And we lost the top to one of these. All right, so that's the chain rule. And we lost the top to one of them, so. Yeah. All right, so there we go. And there we go. And there we go. I think it's long gone. This is the one that's missing a top. Okay. All right, we'll call it a day. I guess so.